Hi guys, so today we have this Commodore 128 power supply that I bought. It's non-working. I'm hoping this is just going to be a short video on getting this repaired. The voltages on this power supply are 9 volts AC at 1 amp and 5 volts DC at 2.5 amps. It's a very big and heavy power supply for that kind of current. You know, to be less than 3 amps, this is it's quite a heavy one. It's a linear power supply. This is 1982, 1983-ish, I'm guessing. And I just bought this off eBay. I don't have a Commodore 128 for this to plug into right now. I have got a Commodore 128D, but that has a built-in power supply. But we'll be able to test these connections. I am hoping to get a Commodore 128 soon, so we can perhaps have another video then. Now this connector, the output pins on this, as you're looking at the connector there, this top left hand pin and the middle pin, they're your 9 volts AC. Top right hand pin is ground, and bottom right hand pin is plus 5 volts. So across these two, plus 5 volts DC, and across these two, 9 volts AC. This pin down here, I think it's just another ground, perhaps the shield ground, but this is the power ground for this one on the top right is the power ground for the 5 volts. So it's these two, 5 volts DC and 9 volts AC. I've not powered this up yet. I don't like powering up faulty power supplies before I've opened them up, just in case I go ahead and do some more damage. The very first thing I want to do is open up the mains plug. Whenever you see a wired mains plug, it's always worth checking that the wiring has been done inside, because of course back in the day these power supplies didn't come with a plug. They just came with the bare wires in the box, and you had to supply your own plug. So somebody else has wired this on. You can also check the fuse racing as well. So let me just get a screwdriver. That looks perfectly fine. That's well wired. You just check that these connections are tight. And they are. And it's got a 3 amp fuse, which is the lowest standard fuse you can get for these plugs, so that is perfectly fine. So nothing wrong there. Now these supplies fortunately have screws, so we can easily open this up. Some of the earlier Commodore 64 ones, you could get power supplies in either a potted version or a non-potted version. I think the Commodore 64C, I think, was a non-potted, but the earlier ones, the early bread bin Commodore 64s, they were all potted. So if anything went wrong inside, it was almost impossible to fix those. But I don't think any of the Commodore 128 power supplies were potted. So if you see one of these for sale that's faulty, you can open it up, and there's a good chance you can get that working. So let's open this up. So most of the weight in this is of course the linear transformer. Got some input protection, there's a fuse there, an input fuse, mains fuse. And some regulation on this heatsink. A couple of smoothing capacitors. There's a little bridge rectifier down there, there's 4 diodes for our 5 volts DC. I'm guessing that the 9 volts AC comes directly from the transformer on a separate tap, and then the 5 volts is derived from another tap, perhaps the same tap. I don't think so though. More likely you've got a separate tap for that. And another fuse there, so I don't know whether that's the fuses for the AC or the DC. Small chip there, I'm not sure what that is. We'll have a look at that. Of course, the wiring could also be damaged as well. Maybe the power supply is fine, but you know, with the use that this thing has inevitably got over the years, it's possible that the conductors are broken, especially close to the supply like this, or perhaps close to the plug itself. So I think what we'll do is we'll unscrew this board, we'll check the continuity on the cable first of all, and then we'll power this up and see what it does. I think the plastic post that screws in is broken, possibly just through being dropped and mishandled, because this is heavy. Yeah, there we are. That one's snapped off. That's no problem though. Our outputs are labelled for us there. 5 volts DC, 9 volts AC, and a ground. Well, this ground I suspect will be the shield ground, so the bottom left hand pin will be a shield ground. Black, obviously, ground for the 5 volts, red plus for the 5 volts, and then brown and white is your 9 volts AC. So let's try the meter, see if the continuity on those cables is good. Plus 5 volts first, which is bottom right. It's good. Ground, top right. Volts AC, so one of these, either top left or middle. Top left, so the other 9 volts is going to be the middle. And then this blue one I suspect is a shield ground, so yeah. Okay, good. So that cable seems okay. Let's quickly check these fuses. This is the mains input fuse, which is good. We have another fuse over here. That one's blown. Okay. So there's two taps on the transformer. This is the main side, this is the low voltage side. There's two taps, so there must be one for the 5 volts, one for the 9 volts AC. So let's have a look. 9 volts AC is these two conductors here. One goes through the fuse and straight to the transformer, and the other straight out. So the 9 volts AC on here comes directly from the taps on the transformer via this fuse. So it's the 9 volts AC fuse that's blown. There is no fuse as far as I can see for the 5 volts, but obviously all of this regulation and rectification is for the 5 volts. Okay, so we know the 9 volts is probably okay. The fuse is blown, but I'm guessing that's because of something that was plugged into the end of here has blown that fuse. There's nothing to go wrong with the 9 volts AC. It just comes directly from the transformer. The 5 volts, let's check that. Let's power it up and check we'll check the 9 volts tap on the transformer, and we'll check the 5 volts DC to see where we are. So let's test the 9 volts tap on the transformer first. Yeah, 10.6. That's AC, of course. And this looks like it just goes through that fuse and then straight out to the cables. The other two taps on the outside, that's for the 5 volts. That's reading 23 volts AC. It's quite high, I would have thought, to regulate down to 5, but it must be right. So let's check the output. I'll switch this to DC and we'll check the 5 volts output. .2 volts, so no output. So we've got our rectifier, the 4 diodes, and then 2 smoothing capacitors. So let's check across one of those smoothing capacitors. .30 volts DC. This is after the rectifier diodes. It's 30 volts DC. So we know the rectifier is good. The capacitor must be good. It's the regulation circuit after that. So let me have a look for the schematic for this and we'll work out what's going on. This is the schematic from the service manual that I've been able to download. And we can see here that the rectifier diodes at the start, so the transformer feeds these rectifier diodes. This goes on to that capacitor, the main smoothing capacitor that we checked over. That was reading 30 volts DC, thereabouts. The regulation is done using a universal switching regulator, and the part number of that is A78S40. And this is quite a flexible chip. It can do step up, step down, and it can invert as well. It can derive negative voltages from a positive input. So yeah, it's quite flexible. The way that it works is via a duty cycle. It basically switches an output on and off, and you can power devices directly from this chip as long as the current is not more than 1.5 amps, and that's from pin 15 and 16, the output. Directly drive a load from those pins, but in the case of this, where the load is higher than that, 2.5 amps, we need some external transistors, and that is V6 and V7 on this diagram. These are two transistors which are switched on and off via the output of the regulator IC, and the duty cycle of that, so the amount of time that it's on and the amount of time that it's off, that will derive the output voltage. So 30 volts in and 5 volts out, it does that via switching those output on and off very fast. What I think we should do with this transformer is first of all test the output of that regulator chip to see whether we are getting a frequency on there. What we should see is something in the range of kilohertz. So I'll get the oscilloscope out and we'll see if we're getting an output on the chip. So we've got the transformer plugged in, oscilloscope is connected to ground, and we're just going to probe either pin 15 or 16. It looks like they're joined together on this circuit. So we are getting an output from the regulator IC. I'm not sure if you can read that, but it's nearly 8 volts and it's fluctuating, but it's round about 10 kilohertz is the output. So that output, if we look at the schematic again, that output directly drives these two power transistors, and that then goes to the output. So looking at that, I would say that perhaps those output transistors have failed, or at least one of them. So what I think we need to do next is check those two transistors. You can see them there on the heatsink, V6 and V7 on the diagram, and they're the ones on the heatsink as well. So these will get hot depending on how much load is drawn, and again, that's anything that gets warm is more likely to fail. I suppose if the outputs had been shorted, so we suspect the output has probably been shorted on the 9 volts at least because the fuse is blown. So if the same had happened with the 5 volts, then that certainly could have damaged one or both of these transistors too. So let me get these unsoldered. They are riveted into the heatsink. So I'm going to need to remove the heatsink and the transistors, and then we can test those. After removing the heatsink, I find that there's only one power transistor on here, not two. The other device, which I thought was a transistor, is a diode, so that is going to be V8 on the schematic diagram. So it looks as though this power supply is a revised version, or perhaps the revised version had two and the older one had one, but this does just have a single output transistor. It's going to work in the same way, so this regulator IC is still going to control that transistor, and the duty cycle of that is going to determine the output voltage. So I think it is just this one transistor that needs replacing here. It looks as though that is the fault. I have tested it on the meter and it's open circuit. All the connections are open circuit on this transistor, so it has failed. I'll need to drill this out because it's riveted on, and then probably bolt it back on afterwards when I get a new one. So I'm going to order a new BD708, and as soon as I've got that, we'll fit it and we'll come back and test this. Power transistor has been replaced and this unit is now back to working condition. So on this one, it was the transistor that had failed. Replacing that has restored power to the 5 volt output, and the fuse had failed for the 9 volt AC output. So I suspect that at some point in the past this has been shorted out. Maybe someone's been probing these pins at the end and shorted them, or perhaps the device it was plugged into was faulty, but I suspect that is what happened. Probably a short on here has caused both of those faults. I've had to screw this back onto the heatsink. There's a little bolt going through the heatsink because this was riveted on. So if you're working on one of these, you'll probably have to drill out the rivet and then replace that either with another rivet, or you could just use a nut and bolt like I have to fasten it back on. I've put some more thermal paste on there as well. I've also, if you notice, put some silicone down here. That's just to keep this inductor from moving around. This was quite loose on the board and it's quite a heavy component, along with these capacitors as well. So I've just siliconed all those together, and it'll just stop it moving around, reduce the risk of any dry joints and things like that. So just before I end the video, we'll just end with a quick test on the meter. The AC output 10.7 and the DC output 4.93. So hopefully this has helped you understand this power supply a little bit. If you've got one that's failed, hopefully this will help you to repair yours. If you have any questions or you have one of these yourself, need something answering, please leave it in the comments below and I will do my best. If you've liked the video, as always, please give it a like for me, and I will see you on the next one.